Let's start recording. Today I would like to work on my compiler interface, which will very soon allow you to interact with the compiler such that it should, as written in the examples. I want this thing to not actually be dependent on this compiler internal header. Rather, I want it to or rather, I don't want the user to include this compiler internal header. That shouldn't be happening. What should be happening is that we create a header, metac type kind h, which mirrors the compiler internal header. But the compiler internal header is generated by an X macro. And this X macro, which you see here, it gets a macro, and that macro gets two parameters. One is the kind, and the other one is the value, right? So what we can do now is we can CTIO. We will need to include the semantic metac type h, since that has the definition. Semantic metac type h. That gives us this. And then we have a main function. Like that. Here, this is the, just so we can remember, the thing we have to keep in mind. Okay, then what we want to do is to generate the metac type h. So the first thing that we generate is the include guard. Include guard. Well, we would, whatever. We can have that look like a macro, since the name will be, I don't know, metac type kind. Is that how do my include guards? Yes, that is how I do my include guards. All right. Then, and also we need a file, right? Yeah. Compiler. And metac type and h. We want it to be writable plus, I guess. No, how do I get rid of this? Maybe I switch to the help of nano. Because I don't. Let's hope it's, yeah, it starts in the regular mode. Okay, cool. And S. So we want first defend that. Fine. And then at the very end, we want this. And then as a comment that and unfortunately that'll fuck up our that will fuck up our syntax highlighting. But only for one line, so it's fine. Okay. Now we do type this enum that after enum and this. Okay. So we have this here bracketed, and then we need a thing that will generate the entries, which is this has to be a macro now because we got to feed that into the X macro. So we define a macro, which should really go like this. Usually you call this what it does. In this case, this is a print member, and it takes a member name, the member value, and then it does, let's print that, indentation S equals %E, comma, N. And then is text member name stringized, then the member value. And we may need to strip the white space, but I'm not sure yet. And then we do for each. I forgot what the semantic multi-type try. Okay, for each type index kind. And maybe we would want them to look different than this. Maybe we would want them to look like that. And that would mean we would need to do some surgery on these. Um, so maybe we just want unknown basic and such. We wanted this. Figure out how long this part is. Easy to do. $13. Wrong. 12. Right. Line 1. Line 12. So 12. But let's see. So this should then not print the. We could do tab index or tab kind. What we called it, right? And then, because we want to capitalize the first one, I want to go from lowercase. There was like was it two upper? Something like that. And then we want the member name plus 13. And then the member value. And that should be that. And in the end, we want to do an F close, and that's that. This has to be about star. And this one needs the well, Alright, and we want the enum name. I don't know. What should it be? Maybe. Let's see. Well, I have like in the in this C file here. Or on the H file. Oh, I called it type kind T. Okay. I mean, fine. But nah, I want to call it MetaC type kind T. Okay. I'm not sure where to operate. Not really sure. So let me grab another tab. C type. Yes, this should be that. And we may need to copy the member name if there are spaces in there, which there may be. But for now, we now have a MetaC type kind, which doesn't contain the things, and it's also missing a semicolon. Okay. Let's insert the missing semicolon. And the reason why it doesn't contain that is because we are not doing the macro substitution. So we now have to do for each type kind. I think it's medicine, and we do print member. Fine. That should be that. Okay. For each method type kind isn't there. What? Recipient medicine type H. Oh, yeah. For each index kind. Sorry. The type index count here. Okay, now this is the C equivalent of template errors. Let's see. I think the easiest thing would be to run it through E. Okay. So let's print this. Okay. To upper. Okay, we're missing a comma here. I think we are only missing a comma. Yeah. There is a missing comma here. I think this should now compile. Okay. Doesn't. Let's see. Open paren fprintf string comma function called to upper. But I'm okay. So that has to go into the function called to upper. The right? Now this looks much better. Subscripted value is not a pointer. Okay. Yeah. That too has to go into parents like this. Vertical. I think this may be able to run. It runs. It doesn't complain about running. It complains about compiling, but not about running. And let's see. Pattern transit. Let's see. Well, this didn't quite output anything. Yes, it's because the fprintf doesn't actually get the file handle. Okay. Gosh, I'm so happy when I don't have to do that anymore. Well, okay, now, no complaints. We run it and almost we have an off by 1 error. So this, for example, should be type def, and the T should be capitalized. So I think all we need to do is we need to do the plus 12 in here. Has to be plus 11. That's it. That has to be plus 12. Yeah. Easy. Metaprogramming is easy, guys. Well, I don't quite like the formatting. I would like to have a tab in here, right? And then maybe have the value in hex. I think I would like 2 tabs. After the name, before the equals. So here. And I want that in hex. Capital hex. Okay, I want 3 tabs. Triple tab. I want triple tab. There we go. For the function tab, I only want 1 tab. For the type def, I only want 1 tab. Template unresolved invalid, I want 2 tabs. Okay. So now we are going to have to do some mathy math. Essentially, what it comes down to is the length of this. Oh my god. We are going to have a complicated ternary expression. Because that's all we can do in this macro. My future me is gonna hate me for this code if I do this via ternary. Okay. We're going to do this data driven. We're going to define a struct which is like, I don't know, type kind info, right? Which is like kind length integer. Kind and like an integer that's the kind value. How about that? And then we are going to fill this. So we can do like that. Fill info. Which is going to put in this. Which is gonna be member name plus 11. Kind len is the len member. And the kind value is the member value. And we can do this. We can do struct type kind info equals for each wrong. There's no equals. Yes. There is an equals for each type x kind. Like this. And we do fill, and then we put it in here. And this will create an array literal for the struct. I'm quite sure this should compile. Is that the case? Or is it the case that you don't need the equals? It's been a while. No, I think you need the equals. So we first to the tab kind info, and then yes. Then comes the name. Infos. Array infos equals. I think like this. Right. Comes here. Initialize element is not a constant. Yes. Yes, yes. There was a way to get around that. And the easiest way is to not store it. There has to be a comma, not a semicolon. Yes, so now we have an array of type infos. We have this type kind info array that contains the kind string and the kind value. And this would be the kind value. And we are also automatically counting how many there are, because we can then do an array size on that. And then we can loop over this. So, well, we can either count how many there are, or we can put in a sentinel. Putting in a sentinel wouldn't be the worst thing. And the way we do this is simply like this. Because this one expands to a thing where a comma's at the end, we can simply add it like this. And then, instead of having this weird construction here, we can do a for loop. For type info type is type info. This will automatically evaluate to 0. If it hits a sentinel, type info plus. That's it. And what we can do here in this loopy loop is we can use the kind string, for example. Oh, it has to, because the point has to be there. And then the kind value. Okay. And then we can do things like star. Like this. Convert to a car. and string we can say current string length just a line of that. Now current string. And then we could just do s print f, comma, current, print c, print s, print ox, print x, comma, n. Right. And now we can do much nicer names. And string, that's 1. And then count value. Doesn't that look way better? And then we can do things like having things in a comment. Yes. Which is like then and D is then and string length. Yeah, because one thing we're gonna want to do is we're going to find out which one the longest is, because we need the longest. So what we can do here, because we can now just loop through this stuff, right? We don't need the value, we just need the string length. And we say finding out which one the longest is easy. Longest. We gotta do this scope so we can define this. Longest length. It doesn't really matter which one, but we need the longest kind name. Let's say max. Max kind name length. Well, we need that outside really. Because we need to access this later, but it's fine. Well, in that case, we don't need the braces here. And it's quite easy if longest max, if it's less than the current, then and only then we want to assign like that. And what we can then do is dynamically compute an indentation, which will go, I guess, here. Yes, and this is then the indent. And the indent is simply the max kind string length minus well, what we can do is we can make an indent string and have that be indexed by the kind string length, or rather not be indexed, but we do a plus, which means this is how much we want to advance. And the indent string simply is max length max kind name length, number of spaces, and then a null terminator. So for the longest one, this expands out to nothing. For the shortest one, this expands out to the number of spaces. Sounds good? Okay. Let's do quick and dirty. Malloc. Max kind name length +1. Sounds star indent string. Well, in order to be compliant with C99, this has to be defined before with C90, I mean. And then we malloc this, we do memset, want to memset it to spaces, and we want max kind name length of spaces, and then we want the indent string of max kind name length to be 0. That's it. And this should now make sure our enums are aligned. I'm quite sure. And we don't need this macro invocation. Yeah. So I think that's it. Well, almost. Let's see. There's something wrong with the type C. Oh. Yeah, I didn't do type def. Okay, let me do type def because diamond of read only location. Oh yeah, this is just a caster, not a const caster. Right. Oh. I think that should be that. And now those are perfectly aligned. Great. The only thing we now need is an indentation, and we're done. Which we can just insert in here. Perfect. I'm not sure if I want the unknown, but why not keep it in? Well, only those are really defined. So what well, we're gonna keep it as is for now. And that's it.